Hello, I welcome you all in this presentation. This presentation is based on the adhesive joining. This is one of the techniques for joining the metals with the other systems also and metal to metal as well. So, here the topic goes in like this: adhesive joining, or this is also known as adhesive bonding. So, as name reflects that the components to be joined are kept mostly either in the abutting position like this, or they are kept in the overlap position. So, mainly the lap joint or the butt joints are made, and between the fang surfaces adhesive is applied. So, adhesive is applied, and here this is adhesive, and after the curing the joint achieves the desired strength to take up the service conditions, to take up the load. Similarly, this is adhesive in the lap joint configuration for developing the bond. So, since this method is so versatile that it can be used for metal to metal bonding or even metal to non-metal bonding also. So, that is why it is extensively used in automobile industry, aircrafts, component joining, and even the construction industry for joining of the glass to the steels, etc. And that is why this finds very extensive application in the engineering industry for development of the variety of components. So, this is how this kind of the joint is developed, and now we will go into the finer details related with the adhesive joining. Adhesive joining basically is found to be, depending upon the purpose, it is of the two types. One is like structural adhesive bonding or non-structural adhesive bonding. So, in case of the structural adhesive bonding, the structural members, like say the two members carrying the load, or they have to support the load, so, and the two needs to be joined with the help of adhesive. So, in this case the load is transferred, load is carried by the joint and it is transferred from one member to another. Load is transferred effectively from one member to the another one. So, this kind of the joint is basically load carrying joint, it supports the load, and the unique part is that this kind of the joint serve the purpose without loss of structural integrity. So, it offers good structural integrity. At the same time, it also offers, in this case the bond area is found to be the large enough, so the stresses are distributed over a larger area. So, what we will say, more uniform distribution of the stresses is observed in case of the adhesive joining as compared to the mechanical joining, which is more commonly used, and that is why this experience is somewhat lesser stress concentration or stress localization as compared to the other processes. So, it effectively transfers the load and the joint becomes the load carrying type, offers the good structural integrity, as well as it allows more uniform distribution of the stresses over the larger area, and that is why the chances for nucleation of the voids and the growth of the cracks become somewhat lesser as compared to the the case when the stress concentration is high, stress magnitude is high. So, this is what is there in structural adhesives. Obviously, the strength of such joint is high and they can carry the load of the service conditions. And on the other hand, non-structural adhesive bonding basically used for the say sealing purpose or just for holding the component in position, holding the joining parts in position. Sometimes for the special purposes also, like to improve the conductivity, thermal or electrical conductivity or thermal or electrical isolation also the adhesive joining can be used. So, these are the purposes of the non-structural adhesive bonding, and they are not supposed to carry the load during the service much. Mostly these are subject to either compressive or the shear stresses. So, the design of the non-structural adhesive bond is not found to be that critical as the structural adhesive bonding. So, basically we will be talking about the structural adhesive bonding and how it is achieved. So, if you see the how adhesives work, like say the members to be joined may be of the same or of the different types. When so, the first step is that all fang surfaces are properly prepared. Preparation is done to remove all impurities like oil, grease, dust, rust, etc. from the surface. So, the surface is prepared and then it is subjected to the pre-treatment. So, pre-treatment further help to avoid the oxides, absorbed gases, moisture, etc. from the surface, and then treatment is also done to activate the surfaces, to make the surfaces more nascent, so that it really helps in wetting as well as the distribution, or you can say spreading of the adhesive between the surfaces. So, as a part of preparation, the surfaces to be joined or the components to be joined, its fang surfaces are prepared, pre-treated and the treated, so that they are more clean and more activated for wetting as well as spreading of the adhesive, and thereafter adhesive is applied. When the adhesive is applied, normally the after application curing is performed, so that the kind of bond being formed can be strengthened further through the interactions between the adherent surfaces and the adhesives. And under this, the various hypotheses have been proposed, which help to offer or increase the strength of the adhesive joints. So, the three mechanisms are there. They can work interdependently, or their role can be interdependent, and they in combined way also they offer the strength of the adhesive joint. One is the mechanical interlocking. Mechanical interlocking basically uses the concept of all the surfaces will have the ups and downs over the surface, and when the adhesive is placed, it will be filling the peaks and valleys present at the surfaces, and all pores are filled in by the adhesive, and once these pores are filled in, it offers the mechanical interlocking by the adhesives after filling in the gaps at the surface and filling in the pores ups and downs present at the surface. Second is electrostatic forces it depends upon the electronegativity of the adherent surfaces, and third is the chemical and intermolecular bonding forces. All these three mechanisms are supposed to work together whenever adhesive joint is made, and it is found difficult to distinguish which of these is working how much for strengthening the adhesive bonds. So, and apart from this, the common adhesives which are used for the purpose of the adhesive bonding, so includes adhesives, includes like epoxy resins. This is one. Acrylic is another, and we'll have there is one or two more adhesives which are commonly used, is like polyurethane and silicone. So, these are the common adhesives. Epoxy resins is a very common structural adhesive which offers very good strength, but this needs curing to achieve the peak strength, while peak strength at elevated temperature, and polyurethane this offers the somewhat low strength of the bond, and the curing happens in this case by the moisture in atmosphere. So, it does not require very high the temperature like the epoxy resins for hardening purpose. So, these are the common types of the adhesives which are used for adhesive joining along with their characteristics. So, it is common that the epoxy resins are commonly used as a structural adhesives, and they offer the desired strength after curing at about 120 degrees centigrade, so that required strength can be achieved. So, apart from this, for achieving the desired joint or adhesive joint with the desired properties must be designed properly. So, the design of the adhesive joint depends upon the service conditions. Whatever design is there, that should satisfy the service conditions, and the service conditions mainly include the load in terms of the type that is static or the dynamic, and then magnitude, the magnitude of the load. So, these are the two factors, and apart from this, the service conditions like environment. This includes three aspects. One is the temperature under which the adhesives are supposed to work, humidity, and the third is any salt environment or corrosive environment which may degrade the adhesives and their performance. So, these need to be kept in mind considering the load, type of the loading, magnitude of the load, and the temperature, humidity, and the other special environmental conditions for the service. The suitable type of the adhesive is selected, and the design of the adhesive joint is made. So, the common designs which are developed for adhesive bonding These include the butt and the lap joint configuration. In addition to this, for designing the adhesive joint, what we have to keep is adhesive joint design. What it includes, basically we have like say the members to be joined, and what we have in our hand is this. The adhesive can be placed between the members to be joined. Since the mostly the metals offer much higher strength than the adhesives. So, adhesives being weaker than the metals, and then to achieve the strength of the joint which is matching with the metals, it is necessary that the bond area is large. So, what we say that to offset or to overcome the lower strength of the adhesives, it is necessary that the bond area being used is large enough, so that the strength of the bond is either equivalent to that of the metals, or it is even better than the in terms of the load carrying capacity of the members being joined. So, the bond area plays a big role in determining the determining the load carrying capacity and the capability to carry the service loads during the service successfully. So, the bond area must be large enough whenever adhesive joints are made. So, the common the joints which are made in lap joint configuration and butt joint configuration, and there is tongue joint configuration, which is a tongue and groove joint configuration. So, these are the three. Apart from this, the some of the joint configurations which need to be avoided includes the peeling situation and the cleavage situation, the kind of the loading which adversely affects the capability of the adhesive joints. So, the typical lap joint configuration works like this, wherein mainly the shear load acts at the joint, and the joint area is designed in such a way that it carries the required the load. So, this experiences the shear load, and this is the lap joint configuration. In butt joint configuration, obviously the plates to be joined or the sheets or the members to be joined are kept in butting position, and between them adhesive is applied after preparing the edges. So, in this case, since the bond area is limited, so the strength of such kind of joint may be lower than the shear type of the joint. Therefore, special joint designs also are made for the butt joint configuration. So, butt joint configuration, in this case the stresses experienced by the adhesive joint are the tensile in nature. Then tongue and the groove joint design, in this case special configuration is made in the butt for the butt joint like this, so that load carrying capacity in butt joint configuration can be increased. So, here we make this is the tongue and this is the groove. So, both one side we have a tongue and another side we have the groove, and the area in this case between these two, the adhesive is applied for developing the joint. So, in this case if you will see some of the surfaces which are, if this is the way by which tensile load is applied, then some of the surfaces will be subjected to those which are perpendicular to the external load, they will be subjected to the tensile load, and some of them will be subjected to the shear load. So, the surfaces of the joint or the joint the portion of the joint which is parallel to the external load will be experiencing the shear load. So, here these two will be experiencing the shear, while this surface and all this surface, these will be experiencing the tensile stresses. So, basically a combination of the tensile and shear stresses will be experienced by the tongue and the groove design. In case of the cleavage type, we will have like say the orientation of the plates being joined is like this, and the component that have been joined using the adhesive in this manner, and load is applied through on the joint itself. So, this kind of the joint configuration is termed as cleavage, and it basically tends to break the joint. This kind of the loading tends to break the joint and offers the limited load carrying capacity. That is why efforts are made to avoid the cleavage joint, as well as the peeling type of the configuration is also avoided, wherein like say the one plate is like this, another is in this orientation, wherein one plate is being pulled like this and another is in another direction. So, this will tend to break the joint easily. This is the peeling joint configuration, and both these peeling as well as cleavage joint configurations tend to lower down the load carrying capacity of the adhesive joints, and therefore, efforts are made in such a way that the peeling and the cleavage joint configurations exist in the does not these two do not exist in the area of the high stresses, but they are relocated suitably so that they fall in the less critical areas where stresses are low, or where the stress nature is compressive or the shear in nature rather than peeling or the cleavage type. So, these are the five types of the joint configurations, and their capabilities in terms of the stresses which are generated and the kind of service conditions under which they support the joint, support the adhesive joint. So, the typical joint configurations which are used for the shear as well as the butt joint configuration will be showing that how to develop the adhesive joints so that it can carry the load successfully. For that purpose, we need to focus on the 2 points. One is our bond area is really large enough, and the second is stress concentration is very limited, because it can start the suppression at the interface of the adhesive and the sheet being joined. So, these are the two factors are kept in mind, and therefore, considering this in mind, the joint configurations, one is the simple one. In the lap joint configuration, joint area, that is the overlap length, is selected in such a way, and the width of the workpiece, it is selected in such a way that the bond area is sufficient to carry the external load. But in this case, we may have the higher stress concentration at these two ends, and therefore, the joint configuration is modified little bit, wherein the section will be having the gradually reducing like this. So, here the change is gradual in terms of the section, and this will have this will help to reduce the stress concentration, especially in the high stress areas. So, this is one typical for the lap joint configuration. Another we will see for there is another approach to do the same, that instead of having a tapered one where the plates are made or prepared like this. So, this will also help to reduce the stress concentration at the edges of the plates. For butt joint, so this is these two were there for the lap joint configuration, which help to reduce the stress concentration at the edges. At the same time, it also helps to increase the bond area. Then we will see the for butt joint configuration, the common one is this one, but since it offers somewhat lesser the bond area, So, to increase the bond area like this is the typical common one, but it is modified in the two ways. One is the simple sheet is kept like this, and another sheet is prepared in this manner, so that the plates and here this area is applied with the adhesive bond. So, this is another modification, say for the butt joint configuration, and another one, there is one more modification wherein like this the plates are, both the plates are modified and prepared in such a way that the plates are exactly in the butting position, and this bond line is used to increase the bond area, or this is how the bond is bond line will be perpendicular to the external load as well as parallel to the external load. So, this will be experiencing both the tensile and the shear stresses. So, this is how we can increase the bond area as well as reducing the stress concentration. There is one more way to increase the load carrying capacity, wherein the double sided plates are used. Like say this is one plate, and then what we will be doing, another plate is brought in like this, another one is brought like this, and between the two the bond is made from the two sides. So, this bond, this is one load carrying capacity, and this is one member, and there are two other members which will be supporting the joint, and the bond area, in this case the bond strength will be doubled. And in this case, further to reduce the stress concentration, we may work in like this, and here we will be providing the center plate, and this will be applied with the adhesive joint in between. So, these are the different joint configurations which can be used for developing the adhesive joints. Now, we will talk about the typical advantages and the limitations related with the adhesive bonding. So, if we will see the typical advantages and the limitations of the diffusion bonding, these are many. The first one, the joint advantages, the invisible joint. So, when just like in welding, the joint at the surface, but in case of the adhesive joint is between the surfaces being joined. So, basically the joint is invisible. This helps to improve the appearance of the assembly being developed. So, this is one, and the second is adhesive. Since adhesive is present between the fang surfaces, between the members being joined, so it does not allow entry of corrosive media or entry of the environment. So, the corrosion resistance, basically corrosion resistance is improved. Further, stress concentration is low because the bonding area is very large in case of the adhesive joints. Thus, this in turn results in the good static as well as the dynamic load carrying capacity of the adhesive joint. Further, it since the metal A and metal B both are good in transmission of the vibrations, but when the two are joined with the help of non-metallic adhesive, it effectively damps the transmission of the vibrations. So, the damping capacity for mechanical vibrations is found to be good when the adhesive bonding is performed. Further, it isolates the A and B. If A is one metal, B is another, then the two are isolated with the adhesive joints, and this kind of suppression or isolation results in the reduction in the galvanic corrosion. So, the galvanic corrosion tendency is also reduced due to the isolation of the base metals and especially in the corrosive environment. Another one is the strength to weight ratio, of these joint is very good. So, the joint is developed even when the load the weight of the adhesive is very little. So, it does not contribute towards the weight much. So, that is why the strength to weight ratio is very good. Another good point is the process is very fast and it is very cheap for the development of the joints. So, these are the many advantages as far as the adhesive joining is concerned. Apart from that, there are limitations like very good quality surface preparation is mandatory. So, proper cleaning, surface treatment and pre-surface treatment are mandatory, otherwise the adhesive bond will not be good. Number 2, the adhesives can degrade in special environments or specific environments, like we cannot use above 180 degree centigrade, or in corrosive environment these can degrade, or in humidity these can degrade. So, there are service limitations related with the environmental conditions. Further, the load carrying capacity of the adhesives become less. So, these cannot be used for very higher load conditions, higher load service conditions as compared to those of which are associated with the mechanical joining methods or like the welding methods. And one more thing is that the process of the curing of the joint is very time consuming to achieve the desired strength. So, it takes really long to not just for the curing purpose, but it needs infrastructure like ovens, fixtures, etc., for the purpose of the curing, so that the required joint strength can be achieved. Now, I will summarize this presentation. In this presentation, I have talked about the importance of the adhesive joining, the factors that matter for development of the successful adhesive joints, as well as the various advantages and limitations associated with the adhesive joining process. Thank you for your attention.